is talking about geometry. That means a shape is involved. And the shape we are talking about when we are talking about trigonometry, as the name implies, tri means 3. It means the study of any shape with 3 sides. And in this case, if you look at this, 3 here and 3 here means 3 sides and 3 angles involved. So trigonometry in a nutshell is the study of shapes with 3 sides, 3 angles, and by extension we also deal with 3 identities and what we call 3 reciprocals. For this explanation to go forward, we are going to look at using a right angle triangle. There are other types of triangles and there are other types of solutions which we'll also go through when we get into grade 11 content. For now, we are starting with laying the foundations, which is grade 10 trigonometry. So previously in grade 9, we dealt with Pythagoras theorem, and we stopped here where we have to calculate the length of the sides and also the sizes of the angles involved. Remember that the sizes of the angles involved in every triangle must always sum up to 180 degrees. So a right angle triangle is actually a triangle with one of the angles equals to 90 degrees. If one of the angles in any triangle is 90 degrees, irrespective of the shape, remember it will be classified as a right angled triangle. And in a right angled triangle, the side facing the 90-degree angle is always called the hypotenuse. It's always called the hypotenuse. Then we also have the other 2 sides that sums up a right angle triangle. We have what we call the adjacent. We have the adjacent, and then we have the opposite. These 2 can swap around depending on the angle you are working in. For instance, if I want to get the angle alpha, then the side facing that angle becomes my opposite automatically, and the other side becomes my adjacent. If I'm dealing with angle theta, here, this becomes my opposite, and automatically the other angle becomes my adjacent. If I have angle theta here, if I have angle phi here, then the angle facing angle phi becomes my opposite, whereas this becomes the adjacent. So the sizes for adjacent and opposite, the size for adjacent and opposites can change depending on the particular angle you are working on. Then we should also remember our Pythagoras theorem, which says that the square of the hypotenuse is equal to the sum of the square of the adjacent and the opposite. So with this, we can calculate or determine the length of any side of a right angled triangle. And the sum of angles, when you add them up, always adds up to 180 degrees. Now, the question is, we can use Pythagoras, the theorem, to figure out the length of sides where 2 sides are given. But in some cases, you only get to see only one side given. What do you do? Because if one side is given, you cannot be calculating for 2 unknowns at the same time. It means you need one more side for you to be able to use Pythagoras theorem. And that becomes a problem. And that is where the other part of trigonometry comes in. Remember, I told us earlier that it is the study of a shape with 3 sides, 3 angles, and 3 identities, and by extension, 3 reciprocals. So this is where the identities comes into play. How do we figure out the identities? We use what we call SOHCAHTOA. SOHCAHTOA means that we have 3 identities, 3 trigonometric identities, which is sine, we have cosine, and then we have the tangent. So this is sine, cosine, and tangent. These are the three identities. And with these three identities, using SOHCAHTOA, we can solve problems involving right-angled triangles. We can solve problems involving right-angled triangle. The word "so" here applies to when you want to use sine as an identity. So means if I want to use sine, then the sine of any angle in question. Let's say, for instance, I want to work on alpha. The sine of alpha will then be opposite. O here denotes opposite. And then this is the hypotenuse. So if I'm dealing with sine of alpha, I will have opposite over hypotenuse as the formula for figuring out this identity or any unknown side if the angle was given. Likewise, if I want to work with cos, the cos here says car, and the car here applies that if I'm dealing with the same angle, for instance, then cos of alpha will be adjacent, that is AR over hypotenuse. So I have adjacent over hypotenuse. And then if I'm dealing with tangent, which is stand for shortcut, then it says TUA. TUA here means that if I'm dealing with tan of an angle, then it must be that these other two sides, which is opposite and the adjacent, are given. This way, we can solve problems involving right-angled triangles where only one side or even one side or two angles are given, or two sides and one angle is given, and that way we can use it to solve problems without having to go back to Python, or in cases where Python will not work for us. So this is the introduction. In the next video, we have to go through and solve some problems using this method.